Here's some guy standing at a drinking fountain. And I think you can all see that there's just one way that one person can line up at a drinking fountain. But now he's joined by this woman. And these two people can line up this way, and they can also line up this way. So there's two ways that two people can line up at a drinking fountain. And then they're joined by this guy, and they line up as shown. But then they can rearrange the line. There's a second way. Now there's a third way, a fourth, a fifth, and a sixth. And if you look all six ways over closely, you'll see that each one is first in line twice, second in line twice, and third in line twice. 6 ways that 3 people can line up at a drinking fountain. And now those 3 people are joined by this person. And there's 1, 2, 3, 4, 5, 6. And you may have noticed what we've done is we've looked at the 6 ways that the 3 people can line up, and we've made a new way for the 4th person by placing the 4th person last in line on all 6 of those ways. But then that 4th person can also be placed second from the last in line, 6 different ways. And then the person can be placed second in line, 6 different ways. And finally, our new person in the group can be first in line, 6 different ways. So we have 4 times 6, or 24 different ways that these 4 people can line up at a drinking fountain. And of course, you might have guessed we're going to look at 5 people lining up. But you have noticed that the number of ways that people can line up has been increasing by a much greater number each time. So rather than try to list or depict with pictures all the ways that 5 people can line up, we're going to go back to the 4-person lineup, and we're going to imagine that the 5th person is placed last in line in each one of the combinations for 4 people standing in line. So there were 24 ways that 4 people could stand in line. So if you put the new person last, there's 24 different ways that the new person could be last in line. Then we're going to let that new person move up to next to the last. There's 24 ways that could happen. Now the new person is right in the middle, the 3rd spot, 3rd from the front, 3rd from the back, 24 different ways. Now the new person is second, 24 different ways. And finally, first in line for the new person. And you see we have 5 24s there. And 5 times 24 is 120 different ways that 5 people could line up. Well, let's look at a chart and review what we've already done. 1 person could line up 1 way, 2 people 2 ways, 3 people 6 ways, 4 people 24 ways, and 5 people could line up 120 different ways. And there's a formula for that. And there they are. The 1 is just a 1, but the 2 is 2 times 1, and the 3 is 3 times 2 times 1, which makes 6. And then 4 times 3 times 2 times 1, which makes 24. And for 5, we have 5 times 4 times 3 times 2 times 1, which makes 120. And there's a name for this. You may already know it's called factorial. And we use the exclamation point as the symbol. So if we mean to do 5 times 4 times 3 times 2 times 1, we write 5 with an exclamation point, and we call it 5 factorial. The factorial of a counting number n is the product of all of the counting numbers less than or equal to n. So for 1, it's 1 factorial, which is just 1. 2 factorial is 2 times 1. 3 factorial, 3 times 2 times 1, or 6. 4 factorial, 4 times 3 times 2 times 1, or 24. And then we can use variables to show how it would work for any counting number larger than 4. You start with the number, in this case n, multiply it by 1 less than n, then 2 less than n, and then 3 less than n until you've counted down to 1, and then you stop. And that's the formula for factorial for counting numbers. And factorial is used in a lot of different problems that involve counting.